Yes, please. Let's move to the next topic, which is a question related with this rule, what we have just finished. Please take 2 minutes, have a look into it, and then we will solve it. It has two parts, A part and B part. Take 2-3 minutes, look carefully, read it 2-3 times, write down the data information given, what to find out, we'll discuss. Yes, please. Let's do it. Sorry, that is A part. So we have to do A part first. Yes, I'm sorry. This is A part. Sorry, you have to do A part first. اوكي شباب اسمع. Now apply the work energy theorem with a known force. Right? Mean the force is given to you. Okay, the driver of this car, its mass is given to you. Okay, this is mass of the car. On the interstate at 35 meter per second, VI slams on his brakes, so the driver applies the brake to avoid hitting a second vehicle in front of him. So once you are driving on the highway, you see suddenly that there is traffic jam, for example, and you have to apply brakes on your car. So you are driving at 35 meter per second. This is the mass of your car, and you don't need to hit that car, okay, which had come to rest because of the congestion ahead. Okay, after the brakes are applied, a constant kinetic force of friction acts on the car. At what minimum distance should the brakes be applied to avoid a collision with the other car? So you need this safe distance, right? Safe distance you have to find so that there is no hitting, no collision, okay, between the cars. So you have to find out this safe distance. You need to find out, right? You have the rule net work done is equal to change in kinetic energy, which is final kinetic energy minus initial kinetic energy. This is half mvf squared. Okay, and of course once you apply the brakes, finally your car will become at rest, so final velocity is 0. Okay, and we have f k delta x cosine of 180 degree equal this. So this will be minus f k delta x. This is 0 final. So you have half Any question, please? Is it okay?
Yes, okay.
Right. Any question, please? Up to here it is okay? F how much? Huh? Yeah. Is it okay? Good. Now F how much? Force of friction. This is force of friction, right? Force of friction is 8 times 10 raised to power 3 Newton. So 8 times 10 raised to power 3 delta x is equal to M, how much? Vi unit delta x will be equal to so delta x you will get this much. Any question?
Teacher, you took the minus from both sides?
Aiva. Minus goes with minus. Any question, please? Sorry? Which one? Last step? Last step? This one? We did it before. This is the rule that work done is equal to change in kinetic energy. You have final kinetic energy minus initial kinetic energy. This is the rule we're using here. So this is work done, and work done is equal to force, which is force of friction, F sub k, displacement multiplied by cosine theta. Theta is 180, right? Because motion is this side and force of friction is this side, right? So theta is 180 degree and cosine 180 is minus 1. That's why we have minus here. Okay, Shabab?
Teacher,
Yes, please.
how do I know V final is 0? How do...
La. You see, you are going on the highway, suddenly you are going with this speed 35, and suddenly you see that the traffic is blocked in front of you. No car is moving, so you have to apply brakes on your car. And once you apply the brakes on your car, finally your car will become at rest. Sir?
Yes.
And when it comes to rest, final velocity becomes 0. Okay. Let's move to the... Is it okay? Should I move to the B part? B part. If the distance between the vehicles is this, now delta x is given to you. Okay. And you have to find out, final velocity. At what speed would the collision occur? So now the initial distance is this much and you are moving with 35 meters per second, and the cars will collide. With what velocity your car will hit the other car? That's the velocity you need to find out, right? Right. Now you see, before the safe distance was 76. So if you apply the brake at this distance, there will be no collision, 76. Now he's asking 30 meter. So of course your car will hit, there will be collision. So what will be the speed of your car at that time? Now you see, work done is equal to half, change in kinetic energy, half mvf square, okay, or you can say and work done is equal to, as I told you, minus Fk del x, because this is work done by the force of friction. It's negative due to 180 degrees. I'm writing directly now because now you are familiar with this. Okay, half m right. So you need this one, Vf. So I keep Vf one side, I take this on the other side, it will become positive, so it will be half and on one side you will be having, now you have half m Vf square half m Vi square minus force of friction, how much? F sub delta x, 8 times. F is given up in the first part, multiply by delta x. Delta x is given to you, 30. So Vf square will be equal to, I take this 2, it will be here, and 1 time 10 raised to power 3 here, right? And then you have 1 by 2 10 raised to power 3, okay, right, rather it will be like this one. Dagi. So it will be, like this one. This will be 1. I'm taking this, 2 and 1 multiplied 10 minus 3, 10 also plus 3 of course, okay. I am taking this 2, it will become up, and this is up, 1 times 10 to 3, it's coming down, right? Now I have all these things here, so this is just mathematics you have to do. 1 by 2 10 raised to power 3 35 square minus 8 times 10 raised to 3 multiplied by 30. Okay, so you would get Vf square, finally you do use the calculator, 745, and taking the square root of both sides, here Vf square, so taking the square root you would get Vf, and here taking the square root 745 you would get like this one. So this is your final velocity which you are asked to find out. With this velocity your car will hit the other car.
लोग गेम पर पैसे लगाकर
Allah. Any question? Yes, please. Any question?
Teacher,
Yes.
when you transfer the kinetic force to the other side, shouldn't be plus, not minus?
You see, you have already on this side with negative signs, huh?
Yes.
The same negative side. And this one you are taking to the other side, so this will become positive, so I have positive here. And on the other side you have only positive half mv square. So I wrote it the other way around. It's the same thing, by the way. Okay.
I'm confused. Still confused.
No problem. No problem. Listen. Look it again, please. Now I am, as I said, this is on this side, sir. Right? On the left side, sir.
Yes.
I am taking this to the other side. This is negative half mvi square. It will become
Positive.
so you are left here with this positive half mvf square, sir.
Yes.
Now this one and this one both are the same. This is one side, so I am writing it on the left side. Why? Because this is unknown. Normally we write unknown on the left side, but I don't change the sign now because I am simply reversing these two. No problem. I'm not taking one only so that it will be plus or minus. No, this is on one side half positive half mv square here, and other side you have the same thing you have here. Khalas. Simply all items from left to right, so we don't change any sign. Okay, or if you want to keep it like this one, khalas, you keep it like this one. You need vf square, you take 2 and m on the other side, khalas. So you will be having on this side vf only. So you will be having all this mathematics here. You will use the calculator and calculate vf like we did it here. Same meaning. Okay.
And if I transfer the half and the other side, it will be negative, right?
Yes, if you take only one, then it will change the sign. But since you are taking all this to the one side and this all to the other side, la mushkila, no need to change sign.
Okay, thank you.
Welcome. Now, should I start the new topic, which is the gravitational potential energy, or we do it the next day? We have 10 minutes, so if you want, I can start, or otherwise we can do it in the next lecture. It's up to you.
Next class, teacher, next class.
Okay, inshallah. Right, any other question, please?
Yeah, teacher, I think it's enough.
Okay, right. Thank you very much and have a nice day.